morning, everyone. I'm Kim, and today I'll explain my answers with a quiz about addressing modes. So let's begin. And this is my answers. And for the quiz, uh, I'll be explaining to you on how I answered it. So for the exercise one, my first answer is register addressing mode. So I answered it. My answer is register addressing mode. It is because it has no brackets. Okay, so first, no brackets. And both of the operands are registers. So that's why my answer is register addressing mode. For the number two, as you can see, it is already showing you the fixed value, which is the 1, 2, 3, 4H, and it is inside a bracket. So that's why it's already giving you the value, and that's why my answer is direct addressing mode. So for the number three, my answer is register indirect addressing mode. So why? First, it has brackets. Okay, brackets. Then inside of it is a register, not a fixed value or fixed number. Sorry, for the number two, it is a fixed number. And the register holds an address. So that is why for the number three, it is register indirect addressing mode. For the number four, as you can see, it is now different from the 1, 2, and 3. It has an addition inside the brackets. So you must also take into account that it is holding two registers combined, which is the base plus index. So with this, with the same principles as earlier, although it isn't the same, but it has connections. So my answer for this one is base index addressing. So for the base index addressing, it's basically a two registers in a bracket. Okay. So for the number five, now you can see here there is a three values, which is the base, index, and displacement. So it is almost the same with the base index addressing, but with the base index addressing, it holds two values. But with this one, it holds three. So this fits with the base index with displacement mode. For the number six, it is the same with number three, where it has a bracket, but inside the bracket, it only holds a single register. So that's why it's register indirect. So for the number seven, the mode AXB minus 10H, it's inside the bracket. So it has a bracket, but it is holding a base register plus displacement. So you can see here that my answer is base index with displacement mode. So why? Oh wait, I might be wrong though. I might be wrong. Well, let me check. apologize for the interruption. So for my number 7, my answer is base with displacement. So why? Why my answer is base with displacement? Because the inside the bracket it contains the base plus displacement. So that's why my answer is uh, base with displacement. So for the number 8, my answer is immediate addressing. The question is mov AX by 678H. So it has no brackets and it is only giving you the literal value of the H. So that's why it's immediate addressing. So for the number 9, the last, my answer is register indirect addressing mode. So why? As you can see, it is the same with the number 3. It is also a register indirect addressing mode. That's because it is a bracket with a register. So yeah. Let's move on to the exercise 2. Okay. So for the exercise 2, I have to write 1886 assembly code snippets to demonstrate the following addressing mode. So number 1, we have the immediate addressings, and I have to store the value of 0x5588 into the AX register. So my answer here is mov AX, then comma 55AH. So why? It's because for the immediate addressing, I have to basically immediate say the value, no? So it doesn't have to be inside the bracket, so just say the value. So for the register addressing, I have to copy the contents of BX into AX. So it says here register addressing, so I just my answer is based on the question itself. Wait, that's like, sorry. So basically with the technique of, so for the first one, I have to type mov. So mov muna. Then, sabi dito, into AX. Kasi, ano siya eh, mov, di ba? Ang answer ko dito is mov AX BX. So, dun sa naging strategy ko or parang naging technique ko, kumbaga, on how I learned it, is yung first na value is i-direct na niya, parang i-deliver na sa gitna. So, ang sinabi dito, di ba, copy the contents of BX into AX. So, yun na sa third placement, yung dito, sa right side, is, mapupunta, or parang, ika-copy niya yung contents kay AX. Oh, so, nasa ba si AX? Nasa gitna. Kasi si Mob, nasa left side. Diba? Nasa left side, si Mob. So, si AX, pupunta doon kay, or makakopy yung contents kay, oh, sorry. Yung BX, makakopy yung contents kay, pupunta kay AX. That's my Mob. So, that's why my answer is mov AX BX. So, now for the number 3, direct addressing, it says here, move the value stored at memory location 1234H into AX. Okay, so without looking, no, itatry natin. So, sabi dito, move the value stored at memory location 1234H into AX. So, this is a direct addressing. So, for the first one, syempre, we have the mov, then we have the AX, then comma, then put the value, which is the 1234H. So, there you go. That's basically the answer because it is a direct addressing. But since it is direct addressing, it is already a given value or parang binibigay na sa'yo. So that's why with the 1, 2, 3, 4H, you have to put a bracket in it. So for the final answer, we're going to have mob AX, comma, then bracket, then inside the bracket is 1, 2, 3, 4H. So next we have the register indirect addressing. It says here, access the memory location pointed to by SI and store its value in AX. So with the register indirect addressing, it is also the same or kind of the same for me with the direct addressing because it puts including there is the bracket. So however, with the register indirect addressing, since it is a register, you have to put a register value. So it says here, access the memory location. Sorry, I will repeat it again. Access the memory location pointed to by SI and store its value in AX. So the answer here is mov, then AX, then comma, then bracket, then inside that bracket is SI. So why? So yung value nung SI is naka-point doon pupunta kay AX para ma-store yung value in AX nung SI. So basically, nag-deliver lang sila. Diba? Ang technique lang sa pag-answer nito is, syempre, given na yung mob sa una, diba? Mob's first placement, then second placement, minsan AX, minsan CX, whatever, AL, ganun. Tapos yung sa third is either the values of whatever, maybe the register, maybe it's the fixed number, diba? So let's proceed. So for the 5, we have here the index addressing. So it says here to retrieve a value from the memory address pointed by the sum of DI and a displacement of 10H and store it in AL. So now we're moving into index addressing. So with the index addressing, it's basically mob, then AL, since it says here to store it in AL. So yung AL yung storage natin, then comma, then bracket, then inside that bracket is we have to it says here to retrieve a value from the memory address pointed by the sum, so it is a plus of DI and a displacement of 10H. So basically, you just have to copy it, what it says. So inside the bracket, you have to put DI plus 10H. So our final answer is mob and AL, then comma, then inside the bracket is DDI plus, or the sum, and displacement of 10H. Then, for the number 6, the last one we have here, says here to base index addressing. Access memory using the sum of BX and SI and move the value into AX. So, with the base index addressing, it's also the same with the index addressing. Pero the difference is what the value stored inside the bracket. So with the index addressing, it is with the example earlier, it is the sum of DI and a displacement of 10H. So with the base index addressing, we just have to make a sum of both the base, then the index, so which is the BX and SI, and move the value into AX. So basically my answer here is mob, then AX where the storage is, then the comma, then bracket, then inside the bracket is BX and SI. Okay, so now let's proceed to exercise 3. So for the exercise 3, we we have here to analyze the following code snippet and answer the questions. We have mov AX inside the bracket SI, mov SI 2000H, and AX bracket SI plus 10H, then inside the bracket, then mov, then inside the bracket DI, then comma AX. So for the first one, we have to identify addressing modes used in each instruction. So for the first one, the mov AXSI, that's inside the bracket, it is register indirect addressing mode. So why? Because it's inside the bracket, and also inside the bracket, it stores a register. So for the mov SI 2000H, my answer here is immediate addressing mode. So why? It's because it's not inside a bracket, and it's basically just giving you a fixed value, 2000H. So for the third one, we have add AX, then comma, then inside the bracket it's SI plus 10H. So my answer here is base index with displacement mode. So why? Why no? So why my answer is base index with displacement mode? So because the first one, as I said earlier, yung SI is the base index, then yung 10H yung displacement mode. So basically, given na yung sagot din, di ba? So that's why it is add AX, then comma, then bracket, then SI plus 10H. SI, yung base index, then yung 10H, then plus, then 10H yung displacement. So that's why my answer is base index with displacement mode. So for the fourth one, the question here is mov, then bracket DI, then comma AX. So my answer here is register indirect addressing mode. Kasi kahit pagbalik-balik ta rin mo yan, di ba? Kung it has the same algorithm. Para saan kasi algorithm to. So, parang sa mata ko nakakita ko ng mga patterns, kumbaga. So, it has the same pattern with the register and direct addressing mode. So, that's why I just put the register addressing mode. Register indirect addressing mode. Just to be clear. For the number 2, it says here, if the value at memory location 2000H is 1234H, and at 2000H plus 10H is 5678H, what will be the final value of AX? So we have to set our SI to 2000H. Then, so basically with the SI, we have to look at the memory box onto where it is pointing to. So with the 2000H with the mov AX, kung iyan natin sa parang kanina, so it will point to my AX, then from the 2000H inside the bracket, it will be equal to 1234H as it said on the instructions. So now we have the 1234H, then we have to take the address in SI and go with the 10H, then with the SI 2000H, so 2000H plus 10H is 2010H. So now we have 2010H, and as you can see here, 2000 plus 10H is 5678H. So with the 5678H, ano na siya, ipagpa-plus mo na lang yung current na 1234H natin, then with the 5678H, di ba? So, pagka-plus mo, actually given na siya eh. Kasi ipagpa-plus mo na lang silang dalawa. Excuse me. Ipagpa-plus mo na lang silang dalawa. So, 1, 2, 3, 4H plus 5, 6, 7, 8H. So, magiging 68 ACH. So, saan nanggaling yung AC? Ngayon, yun yung galing sa hexadecimal. Diba? So, that's why my answer is 68 ACH. So, for the number 5, for the exercise 5, the last one is, wait, let me check my document. Oh. Okay, so it says here, write a small assembly program that loads the value of 0xabcd into the memory location 3000H. It then retrieves this value using direct addressing mode and stores it in AX. Then 3, copy the value from AX to BX using register mode. Then 4, stores the value in BX, the memory location pointed to by the DI using register and direct addressing mode. Then we have to assume that the DI is equals to 4000H. So what I use here is the one compiler, the online compiler. Actually, so my code here is section data, memlock 3000H DW0, then same but with the second line is 4000H. So what? So basically, I simulate the memory to locations 3000H and 4000H, as it said on the instruction. So then section text, global start, then underscore start. Then now we have to load the value of 0xabcd into the memory location of 3000H. So, yung sa first one, yung sa section data, I just parang dineclare ko lang yung memory location, parang may masimulate natin siya. Pero kasi, pag natapos mo itong, pag finalo mo lang yung mismong instructions, mag-work siya, pero it doesn't really require you to produce an output. So, long story short, my code output doesn't output to anything, though it doesn't also put an error. Pero basically, dun sa inside ng code mo is nagagawa na yung kung ano man yung sinabi na to, which is to just basically copy, retrieve, and store. Then, so let's continue. So, for the first one, mov word memlock underscore 3000H, and the memlock 3000H is inside the bracket para dun mapupunta yung 0 A, B, C, D, H. And just to clarify, the code can be different depending dun sa compiler mo, because I tried some other kind of codes, pero it doesn't work on the specific compiler, so I have to adapt it to that compiler, which is the one assembly. Then my next is we have to retrieve the value using direct addressing mode and store it in AX. So what we have here is mov AX, word memlock 3000H. So basically just nire-retrieve nyo lang yung value. So for the number 3, we have to copy the value from AX to BX using register addressing mode. So we have the mov BX, then AX. So, bakit siya naging mov BX and AX? Mov BX, AX. So, basically, i-copy mo lang yung value from AX to BX. So, from AX to BX, kung saan nagsimula, sabi ko kasi kanina, sa third placement siya. From AX to BX. Dito yung move. So, ayan. So, for the number 4, I have to store the... Let me change this color. So, okay. So, store the value in BX The memory location pointed to by the DI using register and direct addressing mode assumed that DI is 4000H. So my answer here is layer RDI, memlock 4000H, then mov word RDI bits. So basically, these loads, yung sa layer RDI, para ma-load siya effectively by the address from memlock 4000H into RDI. So, and the second one, with the mov word RDI, then the RDI is inside the bracket, comma BX it stores the 16-bit value from BX into the memory location pointed by the RDI. Then, with the lastly, so ayan na, so nagawa na natin 1, 2, 3, 4, pero hindi pa dun mag-end. Ayun nga lang pagdating sa assembly, parang may entry, then entry tapos exit. Kasi, it's my first time coding with the assembly, pero medyo ano din siya. Since hindi pa ako familiar sa algorithm niya or dun sa patterns, kumbaga. Medyo mahirap-mahirap ng onte. Pero, I think, you can get used to it. So, yeah. So, exit program, then move RAX, 60, then move RDI, 0, then syscall. So, basically, yung move RAX, then yung move RDI is, yung 60, system call for exit. Then, yung 0 naman, exit code 0. Then, yung syscall is to execute the system call. So, yeah, I think I explained it all naman. And that is it, guys. So, yep, that is all, guys. And thank you for watching. And it's very early in the morning. So, yeah, have a good morning and eat your breakfast. Bye-bye.